All right, so going back to the inequalities that you were testing last class, let's use one for me, say the one we were talking about yesterday. 5 is less than 6, and I've made that true now. So if we say add 4 to both sides, we would get 9 is less than 10, which ends up being a true statement still. So adding 4 to both sides of an inequality does not change the truth value of it. Now I could do the same thing with subtraction of 4. So if I subtract 4 from both sides, 5 minus 4 would be 1, and 6 minus 4 would be 2, and yes, 1 is still less than 2, so that is a true statement. Now I get to multiplying, so I have 5 is less than 6. If I multiply 5 times 4, I get 20, and 6 times 4, I get 24. So yes, 20 is less than 24. Dividing by 4, I have 5/4 is less than 6/4. And yes, they're both out of fourths, and obviously 6 out of 4 or 6/4 is more than 5 out of 4. Now we get to multiplying by -4. So 5 is less than 6. If I multiply by -4, I would get -20 is less than -24. These were true. And that is where we get to a false statement. So remember, on a number line, the further we get into the negatives from 0, the further away it is. So those negative numbers are actually look like a larger number, like 24 looks larger than -20, and actually this is not greater because it's negative. So that makes the statement false. If we do the same thing with dividing by -4, we would have 5, so -5/4 is less than -6/4, and for the same reason as in E, the larger negative actually makes it smaller, so this is also a false statement. So where this is going to apply to us is when we're solving inequalities by isolating the variable, just like we have with equations. We are going to need to pay careful attention to when we multiply or divide by a negative number, because that's going to affect the truth of our final answer. All right, so you should title this section of your notes, Graphing One Variable Inequalities. An inequality, which we explored yesterday with that Desmos activity, is a relation between two expressions that are not equal. So it's a comparison. We have different symbols that we will use for this comparison, one of them being greater than, and that's us reading from left to right. So the quantity on the left will be greater than the quantity on the right. We have greater than or equal to, which we discussed yesterday. If we have a line underneath, that's going to actually include the value itself, and that would be a closed circle. You can see that underneath here. We have less than. The reason I usually remember this is it looks somewhat like an L if we're reading from left to right. The quantity on the left will be less than the quantity on the right. We also have less than or equal to when we have a line underneath that is indicating it's also equal to. And then we have our symbols that go with those. So we would have an open marking at the value and pointing to the right if it was greater than but not equal to. That same direction but filled in would be greater than or equal to. And then pointing in the other direction to the left, if it's an open circle, that would be just less than, not equal to, and then with a closed circle, that would be less than or equal to. All right, so I want you to pause and copy down these 4 examples, and I want you to graph them appropriately. So depending on an open circle, closed circle, what are these graphs going to look like? All right, so after you took a second to graph these, here's what I put the solutions as. So we would read this as n is less than or equal to -5. I have a closed circle and I'm pointing less than. You might notice that the way the inequality is facing also matches the arrow. Oops, I don't know, I'm having trouble writing, but the arrow on this graph right here points the same way as the inequality symbol. Okay, we have the second one, r is greater than 2. So here we are at 2, it does not include 2, and it's greater than. Also, just like I pointed out on the previous one, we have that symbol. And over here we also have a matching symbol. Our little alligator mouth, as you could call it, is opening up to the left just like the arrow. Number 3, we have x is less than 1. It's not going to include that number 1, and it's pointing less than. And then we have x is greater than or equal to 2. That is a closed circle pointing greater than 2. Alright, so here's some rules for solving inequalities. You're going to find them really similar to the rules steps we have for solving equations. So whatever you do to one side of the inequality, you must do to the other side. Things have to stay balanced. You want to get rid of the constant first. We have been talking about the fact that we're using the reverse of order of operations, and I keep calling that PEMDAS backwards. We start with undoing addition subtraction first in most cases, which involves getting rid of our constant. If you have fractions, get rid of the fractions first and then proceed with solving the inequality. And, you know, that might involve having something like this, where we want to get rid of that fraction. So let's look at an example. We have our inequality, 2y minus 5 is less than 7, and we want to solve it just like we would an equation. So we're going to be separating our two sides of the inequality. We can circle our variable, focus in on that, and then we will want to get rid of the -5 by adding 5 to both sides. And that gets us to y is less than 12. Then I would divide, 12. Then I would be dividing by 2, and I'm getting left with y is less than 6. And I could go on to graph this similar to what we did on the previous page. Alright, here's another. So I may need to do some extra steps of combining like terms or getting rid of our parentheses first. There's actually a couple different ways I could do this. I could get rid of my 2 at the beginning by dividing, and that's because this is all being multiplied by 2. So I'm dividing it all by 2. It's all multiplication happening right here. I can do that on the other side, and I can have 3 is greater than or equal to x minus 4. And that actually worked out nicely because the 6 is divisible by 2. Now I would go on to isolate my variable here by adding 4 to both sides, and I get 7 is greater than or equal to x. So as we discovered in our little warm-up investigation, whenever we multiply or divide by a negative number, we're going to have to reverse the sign. And I can just show that simply by multiplying by -1 to both of these. I get -3 is less than -5, which is not true. So to make this into a true statement, I'm going to need to reverse that inequality symbol anytime I do this while solving an equation. Alright, so let's see that in action. So I'm going to balance my equation. Oopsie. Box my variable, and I will be getting rid of my constant 6 first. Subtract 6 from both sides. I get -6 is greater than or equal to -3/2 x. Now I'm going to multiply both sides by the reciprocal to get rid of this fraction, which would be -2/3. Notice this is the point where I am multiplying by a negative. I can cross simplify here by dividing by 3, which makes this 1. -6 divided by 3 is -2. And now I have -2 times -2, which ends up being a +4. I'm going to switch the direction of my inequality, and I'm just left with x on the other side after these multiply and give me 1. So this would be 4 is less than x. Alright, here's one. I want you to pause the video, try to solve this yourself, and then when you resume the video, I will have the solution for you. Alright, here is the solution to this. At no point did I perform an operation of multiplying or dividing by a negative to each side, so there's no need to flip the direction on the inequality symbol, and I get x is greater than -1/3. Alright, we're going to have one more example that you do on your own. So pause the video. Alright, so on this one I have combined like terms. Got my simplified inequality, and then because I am dividing by -3 on both sides, I have switched the direction of my symbol to get x is less than or equal to 7. Okay, gonna skip ahead a little bit. Sometimes we have situations where our solution to our inequality might be infinite or none, like we have seen with our equations and variables on both sides. If we get rid of all of our variables and we end up with an inequality statement that is true, that is going to be our infinite solutions type of situation. We also refer to it as all real numbers. So it's going to span, it's going to go on infinitely, it's going to cover all of the numbers. In the same sense, if we get a result that is false, so something like 3 is greater than 4, or we had 5 is greater than 6 in our Desmos example, that is a false statement, and that would indicate that there is no solution. Alright, so if there's any part you need to go back to and listen to on this video or copy down some notes, make sure you do, and we will move on to some practice.